Hello and welcome to MEL Science. An absolute joy and a pleasure, a privilege indeed, to have you on the webinar this evening. Let me just change my screen so I can see. This is a live webinar, and if you're happy to do it, you can make your screens go live. So I can actually see it, makes it a little bit more personal. You don't have to do that, but at least also helps me sometimes see if you've got some issues or some difficulties. And you can put your hand up in any case. I think we've got, we're 10 of you here today. We've got Izzy, we've got Claire, we've got Jeff, we've got Andrew, we've got Amelia, and we've got iPhone. The ever anonymous iPhone. And Tobias, if I've got your names wrong, Jeff. Hello, Jeff. And little Jeffette. Hello, little Jeffette. Lovely to have you here, and thank you very much for subscribing to MEL and staying with us. I've got some, hello Jake. Jake is back, fantastic. Jake, I hope to see you for ages. So nice to have you, and I hope you're all well. Let's just get rid of those starty doodahs. Cool. So I've got Jake and Izzy and Pearl and iPhone and Tobias, I think, hopefully, and Amelia. So today, welcome back to MEL in January, so more or less the sort of start of our sort of joy, sort of 2022 sort of skid through the science of MEL. So let me just quickly remind you all, we are now doing the battery. So this is the Zinc-Carbon Battery. And what I'm going to do is, Jake, then just quickly, just for the sake of, as always, then I'm just going to switch cameras for you so that we can have a look and see, just check the equipment that we need today. Okay, cool. So the two experiments that we're going to do today, we're actually going to do two or three of them, is the liquid wires. We're going to look at liquid wires, and then we're going to look at the zinc battery clock. We're going to create a battery and make a clock out of it. So in no particular order, just quickly check that we've got all of the equipment that we need. And so another live camera. Amelia, hi Amelia. You've gone live. Okay, so we need our crocodile clips. We need our battery holder, our cell holder here, look. So you do need, for this set, you do need two AA cells. So you need two AA cells, of course, and I will explain that in a second. So two of those, and ideally they need to be nice and fresh. I'll just switch to tabletop with face so I get this a bit more personal this way. Okay, so you need the little tiny test tube sample pot here. You need your spoon. You need your safety specs. You definitely need some gloves. I've just forgotten. Oh, my gloves. Let's just quickly get those. So you need some gloves. Now your gloves, of course, come in a little box like so. Right, you also need the two zinc-coated bolts. There's two zinc-coated bolts. Another screen has gone live. iPhone, it's Mr. iPhone. Hello, iPhone. You then need 4 of the little tiny absorbent pads. So these little tiny absorbent tubes. You need the little tiny bottle stopper. So little tiny bottle stopper. You need 2 of the carbon rods. So these 2 little carbon rods, they come in the pack. Then you also need, you don't need both of the LEDs, so these are the light emitting diodes. You can just use one, but they're different colours, that might be prettier for you. You also need, as usual, the little safety seal plug paper clip here, so to depress the safety seal out of the tube. You need the 2 little tiny rubber tubes. Those are going to be our batteries, so these are the body of the batteries that we're going to make. You need a little stirring rod, the little tiny funnel rather. And then obviously your tray, and let's go through the chemicals that we're going to use today. So the first chemical in no particular order is graphite. Now you notice this is a black graphite tube, so it says 1 gram of black graphite powder. So don't forget that's the same as these black, but these rods are being compressed. That's compressed graphite. You need the liquid glass, so liquid glass. You also need the yellow graphite, so basically the same thing, but we're just going to use a whole one of the other and part of another one. We need the ammonium chloride, so the ammonium chloride, and then last but not least we need the manganese oxide. So those are the chemicals that we need today. So that's all of the equipment, and you also need 2 bits of paper. We don't need 2 bits of paper, actually we just need 1 bit of paper here in which to draw our electrical circuit. Okay, is everybody okay? So occasionally, this is live, okay, so it's actually a live thing. You can ask me to stop, you can ask me to slow down. All you've got to do is put a thumbs up or ask me to unmute and I can unmute you. We've got a nice little group today, so it's very personable. So hopefully we will be fine. Right, so just move that out to one side. We're going to start today with the circuit. So we're going to start today with that electrical circuit. And I'll just pause just for a second to see, is everybody okay? If I put a thumbs up and I get a couple of thumbs up, I'll then think that everybody, yes, cool. Brandon, you have changed from the anonymity of iPhone to Brandon. Fantastic, Brandon, lovely to have you on board. To us, Henry says yes, although Henry doesn't look like Henry in the profile, looks like Mrs. Henry. Izzy and Mel and Jeff and Amelia, fantastic, cool. Right, I'm just going to get my gloves on. Now, just one small warning here, guys and girls. This is very potentially messy, so I highly recommend that you make sure that you are operating on your little white lab dish at all times, okay? Because you are very, very, very likely to spill black carbon powder and it gets everywhere, okay? It gets everywhere. So stable hands are required here, stable hands. Okay, so what do we need for the first one? So first I'm going to move all these ends off the, empty my little tray and just take what we need out of this. So we do need the 2 cells. We need our battery packs. This is the pack. We need your crocodile clips, your leads. And just to remind you, okay, when you get your crocodile clips like this, they've got a protective covering. So all you've got to do, look, is just push very gently the covering back like so. And that shows you how to use them. So it makes them much more user-friendly. So just pull them back, just slide them back like that. So we just expose the little jaws of our crocodile clippings. Okay, we need the tube. We don't need our battery, not making a battery just yet. Okay. So we need the funnel. We don't need the funnel there. We need the chemicals. Hang on. Just move that to one side. We do need the little LED. So put any one of those LEDs that you choose, you can use. We do need the little snout, the little bottle top. I'm going to move the other LED to one side. And then that's where we're going. So the chemicals we actually need to do, of course, are the liquid glass. So if you get your liquid glass, so this one here is the first one. And you also need the graphite. So this is the black graphite tube. Let's take the black graphite tube. Okay. Hopefully that's okay. And then last but not least, we do need our little bit of paper. Okay. Right. Everybody okay with that? Everybody okay so far? Yep. Cool. Nice one. Right. So the liquid glass, first of all, what we're going to do in this particular experiment, we're actually going to show you how you can use graphite, okay, so the carbon element here, number 6, we're going to use graphite, powdered carbon, and show you that it can be used to make an electrical circuit. You can actually paint an electrical circuit. So if you press down on the liquid glass, and we just need to depress that little safety plug out of the nozzle. So let's do that quickly. Mine's a little bit resistant, so sometimes, as you know, sometimes they might be a little bit stiffer than others. So just keep wiggling it away and it will eventually pop into the bottle. There we go. Fantastic. So again, sometimes it might be a little bit sticky, so don't panic about that. Right, then what you need to do is open up your graphite. So this is the powdered graphite, okay? And you're going to squeeze the whole bottle, so put the whole bottle of your liquid graphite into the graphite bottle, okay? So just squeeze the whole of that liquid glass into the graphite bottle here. So put that all in. So the whole bottle goes into the graphite pot. At this point, hopefully there shouldn't be too much mess. Right, so that's now nearly all of the liquid glass. So put that lid back on there and put that to one side. Oops. Okay, now the next thing you need to do, now it's very, very important, this is kind of an odd little sticky mix. You probably notice if you drop a drop of oil into some flour or to some sugar, it just sits there like a skin forms, it just sits there. So we've now really got to work hard to mix the graphite into a thick, slimy paste, okay? So here, for about 30 seconds, you really need to work that paste and give it a really good wiggle round, okay? So give that really good wiggle round. So don't be afraid to get very active with that. Really go on, work it hard, okay? So about 30 sort of seconds. So while you're doing that, I'm just going to quickly look at a slide. So I've got a couple of little slides for you just to explain what's going on here. Okay, so here is the Zinc-Carbon Battery set. So that's what we're looking at today. And so basically, while you're wiggling, so keep wiggling. So basically, what is electricity? That's what we're talking about, zinc-carbon battery. So electricity fundamentally is the flow of charged particles. Okay, so when you see electricity anywhere, it's the movement of charged particles. Now those charged particles can either be ions or electrons. So electrons themselves is largely electricity, but it can also mean charged particles. Like here, I've got an ammonium ion here. Okay, and we're talking about batteries. And a cell or a battery is a power supply that basically allows you to push electrons around or charges around. Okay. And then we'll come back to the circuit in a minute. How's the wiggling going? How's the wiggling going? All okay? We thoroughly wiggled and thoroughly mixed. If you just take the I'll just quickly swap my camera here a little bit. If you just take the rod out just a little bit, if you see on the edge of the rod there that it's a nice, even, cohesive, thick sort of sludge, then we're done. So that's about right. So here, so just take the rod out. So just very gently, look, if you take it out and just gently bring it across the edge of the little tiny reagent bottle here and try and scrape off some of that sort of sludge. Okay, very carefully like that. Okay, and then you need to put that down on some, I would advise you put this on a little bit of paper somewhere, a little bit of tissue paper. I'll just stick my face on that one, face camera, hang on, face. With face. Okay, I'm just going to use a little bit of tissue paper to put that stirring rod on. Okay, now, if you then get the little bottle top, the little bottle top here, I don't have liquid glass. Izzy, oh, I'm so sorry, I missed the chats there, so sorry. Pearl, what do we need? Oh, hopefully, Pearl, you've got all that. I hope, Pearl. Izzy, I don't have liquid glass. I have zinc, is that right? Izzy, I think you've got the wrong kit. I think, Izzy, you might be using the tin kit. Izzy, is that right? Amelia, no, wrong pack. Yes, sir, Izzy, and thanks, Amelia, for adding that. I think, Izzy, you've got the tin kit. Yeah, hi, Izzy. I'm doing tin next week, and also you can pick up the previous tin live webinar recordings if you want, but I'm doing, I think, tin next week as well. So if you want to join back in on the tin webinar next week, that will be fine. Okay, cool. Thanks ever so much, though. Thanks ever so much. And hopefully see you next week. Okay, right. So now what we need to do is put the little bottle topper onto there like so. And now we're going to create a liquid wire, a liquid conducting wire. Okay. So using the edge of your paper, look. What you then need to do, look, is just squeeze the bottle. Now it might be that you have to give this a real shake. So just give it a little shake down, hold the end of it like that. In fact, if you want to just put the top back on the bottle like this, look, and give the bottle a good shake like that. Like that, so, okay, so once you've given it a big shake, you should then find that the wire, you can actually, draw a wire, a carbon wire, like so, okay. So I've just drawn a little wire like that. Okay, so you can see it's a nice thick, it's like a little worm, like a little sort of carbon worm, okay. So once you've got your little carbon worm, then we need to set up the battery pack, okay? And making sure you've located your little LED. Right, so this is important again. You see where the springs are? The spring is the negative end, and that's the flat end of your cell, okay? So if you put the flat end of your cell, so set up your battery pack. So these are cells, these are commercially available cells. And what we're going to do in this wonderful lesson is we're actually going to create our own homemade cells. Okay, and you see how easy that is to do. Okay, so connect up your battery pack like so. Next, we need to connect up the leads. So red to red and black to black, obviously. So connect up your leads like so. So red to red and black to black. So red to red and black to black. Okay, so we connect up our leads to just check that everybody can see that. And I'll just move that to there. Okay, so zinc actually. Is everybody okay so far? Yeah, we're okay? Yeah, thanks Jake. Amelia, Jeff and Brandon and Pearl and yep, we're okay. Cool, lovely. Now, what you now need to do, okay, is make sure on your battery pack, if you see on your little list here, it just shows you just to make sure where the connections actually are, okay? You're going to use the black lead, okay, the black lead there to make sure the little crocodile clip is biting into some of that carbon sludge, okay? So make sure that the black lead is biting into the carbon sludge. I'm just going to turn off a bit of my lighting here so you can actually see, hopefully, the LED actually come on. Now, the next thing is you get your red lead, and the red lead, if you see your LED, look, your little LED has got a bent leg and a straight leg, a bent leg and a straight leg. The LED, the crocodile clip goes onto the straight leg, okay? The straight leg like that. So hopefully you've got a nice little bit of a bent leg like that. So put that red lead on the straight leg, okay? And then you put the little foot, the other little foot of the LED somewhere into the sludge you've got. So somewhere look into the sludge. And with any luck, the LED comes on, bing! Isn't that cool? So hopefully you just touch that little LED there and you can see the little light comes on, look, the little LED comes on. So this carbon, you've actually created a carbon sludgy circuit. You actually painted your own sort of circuit. Is that not, or is that not cool? Are we working? Now it may be, if you're working in a very bright environment, you might want to turn the light down a little bit, because the LED itself is quite a light low, so you might want to turn the lights down a little bit. Jeff, you see that kitchen looks a bit bright, and Brandon, it looks a little bright where you are, but Amelia, you've got a perfect environment, perfect, really dark. And if I just switch off, I'll just briefly switch off most of my lights so you can actually see my little LED. Come on, you're right, Jake? Jake, yeah, cool? Not working? Give me 3 seconds, give me 3 seconds. Hang on, switch that back off. And I'll just switch this one off. And then you can see, look, if I just touch the sludge again, hopefully everybody can see that. Okay, I'll switch my lights back on and let's just see if we can. Right, who's got some problems? Switch that back on, switch that back on, and switch that back on. Okay, who's got problems I can help with? Who's got problems there? Oh, hi Henry. Who needs help? Jake, asked to unmute Jake. Hi Pearl, great, working, brilliant, brilliant, nice one Pearl, thank you, that's great. Jake.
Hi, even though I've done everything correctly, when I dip the bent leg into the sludge, it still won't turn on.
It still won't turn on? Right, is the sludge really nice and uniform sludge?
Yep.
Yep, so that's properly mixed. Okay, cool. Is it a nice thick sludgy line?
Yes it is.
Yeah, it's a nice thick sludgy line which should be going reasonably hard. The crocodile clips, are your batteries, the cells, the individual cells, were they brand new?
Yeah, they were.
And have you checked that the crocodile clips themselves are biting onto the ends of the leads securely? Because I know I can... Amelia, perfect. And Jeff Hall, perfect. Look at that. Absolutely wonderful. Wonderful. Isn't that clever?
Yeah, they were all correctly.
Ah. Then Jake, have you tried another one of the LEDs? Sometimes the LEDs don't work. Sometimes they don't work. Hopefully that's okay. Hopefully that might fix the issue. Anna has just joined. Hi Anna, is that all working? So Henry's working, Pearl's working, Amelia's working, Jeff all working. Fantastic. So we've got some conductive sludge. That's wonderful, brilliant, absolutely fantastic, Henry. Thanks very much for that. Great. So Jake, I think it might just be you got an LED issue. It might be an LED issue. Okay, cool, brilliant. Right. So, just to quickly explain a couple of bits of terminology, and then what we're going to do is we're going to go on to the next experiment. So I just want to explain a bit of mine was an LED issue. Jake, if it helps, Jake, Pearl's just put into chat that she had an LED problem. LEDs very often don't work, so that's why they sell them in packs of hundreds for a couple of pence, so they often have a problem with that. Cool. Okay, right, so... slideshow. So what we basically created here with our battery pack, okay, is a capacity to push electrons around an electrical circuit, okay? And some of the terminology is really very specific. So some of them are very important. So the difference between a cell and a battery, okay, a cell is a single one of these items here. That's a cell. That is not a battery. And it has this physics symbol, okay? So one big positive side and a little negative side, okay? So that is a cell. When you say battery, you mean two or more of these. Okay, so a battery is at two or more of those. And then you have the positive and negative side again. And then however many you've got in between. You just got to write those numbers in. So that's the difference between a cell and a battery, okay? Now, what you've created here is what's called an electrochemical cell. So an electrochemical cell is basically a device that uses a chemical reaction. You actually have a chemical reaction in your battery. Now, we're going to create this. We're going to do this bit of magic now. It's a chemical reaction that creates the flow of electrons. And then what we do in that circuit is we make the electrons, they've got some energy, okay, and we make them do a bit of work. So like in this case, we basically made the LED come on. Brandon says, unfortunately, Brandon doesn't feel weak, so we'll be watching this at a later date. Thank you for saying. I'm so sorry, Brandon. Please, I wish you a very speedy recovery, and don't forget this is a recording, and so you can watch that at a slightly later date. So really, hopefully you're okay, and I wish you the very best, and get well soon. Okay. So thanks for joining, Brandon. Okay. So see you later. Okay. Cool. Right. So if we move a little bit further ahead. What's in a typical alkaline cell? Well, we'll come on to that because I'll come back to it once we've built our own. So let's crack on and build our own. Right, so just quickly, are we ready to build our own and make a little clockwork? Are we ready to go for that? Yep. Cool, right, let's build our own. So back to tabletop with phase. Okay, so what do we need for that? If you disconnect now all of your apparatus, now you'll notice, as I said, you've got this sticky gunge everywhere, so my little hands are full of gunge as well, so yours will be, I'm sure. Don't worry, it all comes off with warm soapy water, so warm soapy water and you can make it all come off. Okay, so if you take the cells, so disassemble your battery, so take those out, because we're actually going to make our own now, so it's a Zinc-Carbon Battery. So take those out, and put those to one side, disconnect your crocodile clips from those various components, okay? And just put that to one side. So just leave that to one side, okay? And we can come back to that a little bit later. Right, now what we're going to do is we're going to do the Zinc-Carbon. We're actually going to make our own battery, which is really super cool. So what do we need for that? We need the graphite. We need the graphite, look, in the yellow container. So graphite in the yellow container. You also need this manganese oxide, so manganese oxide, and you also need the ammonium chloride, so ammonium chloride. So those are the chemicals we need. Then next we need the two tubes. This is our battery body. This is going to be our cell body. So that's a cell and that's another cell. We need our little scoop, our filter funnel, 4 of the little, or rather just 2 of those will do actually. 2 of the little tiny filters or absorbent pads. We need the 2 of the little carbon rods. We need 2 of the zinc tablets. And then you also need the clock mechanism that comes in your kit. Did everybody get a clock mechanism with their kit? Yep, everybody's got a clock mechanism. Fantastic. Okay, so grab your clock mechanism. I'm just going to quickly make sure we've got that. So clock mechanism there, and that's my little clock mechanism back, and that's my clock face. Okay, so those are the bits, the components that we actually then need. Okay. Now we need to do a little device here which we're going to do all the mixing of the reagents, okay? So I'll just quickly check to make sure everybody's okay with that. Just have a quick thumbs up. Yes, everybody okay? Yep, we're cool. You got it, everything? Yep. Anna, I'm assuming Tobias. Yeah. And Jeff, and thank you so much. Amelia, we're all good. Excellent. Thanks, fantastic. Right, so let's crack on. So using your little container, our little mixing device, okay? The first thing we're going to put into that is the graphite. So you're going to put 1 whole bottle. So the whole of this bottle goes into the container. So you can just pop the whole of that bottle, look, into the container. So just give that a tap. And just give it a quick tap until you've filled the whole of it. You've all of that bottle, all of the graphite, into the container. Now do not throw this container away because it's got enough in it to make another cell, okay? So just give that a little tap look on the top to make sure it's all in. So I think that's all in now. Put that lid back on. And the next thing we need to do is the whole of the manganese oxide. So you need to pop the whole of the manganese oxide into there. So again, undo the top. Notice they're all powders here, of course, at this stage. So pop the whole of that pot in. All of that goes in. Okay. Now just be careful. You might need to wiggle it around a little bit because sometimes the powder hangs around in the shoulder of these little reagent bottles. So you might need to give that little wiggle like that, okay, to make sure it's all in. Okay. Right, now put the blue top back onto your little sample container and just give that a really nice shake for about 30 seconds, okay? So put the little lid back on that and give that a little shake. 30, 29, 28, 27, 26, 25, 24. There's some good shaking action there. Obviously you guys are well practiced in the shaking department. Good to see, excellent to see. Professional shaking all round. So what we've got here is some very fine powders, okay, with carbon, so elemental carbon and manganese oxide. Nice action, Jake, nice action. Tobias, Pearl and Anna, of course, staying. We don't have a kit this week because we signed on yesterday, but we are enjoying watching. Lovely, Anna, thank you so much for joining. Thank you so much for watching. Great. I think your first kit will then be tin. So I'm doing the tin one next week as well. So hopefully we'll see you again then at that point. But do please keep watching. That's great. Thanks ever so much. So shake, 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 shake. I think that's about right. Yeah, so about 30 seconds, and you should have a nice sort of clumpy mix in your little reagent bottle there. Okay, cool. So next, let's start to assemble our first cell, okay? So if you take one of the little tiny carbon pellets, okay? So just take one of the little carbon pellets and one of our rubber tubes. Nice one, Jake, lovely, already ahead of the game, fantastic, that looks great. So just wiggle that into the base of the tube. So just wiggle, 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 and push it into the tube. So you want a little bit left out. So about, if you just push it about halfway in, so leave about half of it out, or about a third of it out, okay? Hopefully everybody's okay with that. Just check. Ben has just joined. Hi, Ben. So just join there. So you want about half of that out, okay? Now the next thing you need to do then is turn it upside down. I'm just going to bring this a little closer for you so you can actually see everything here. And put the filter funnel tube into the mouth of the other side of the tube like that. So fix that in like that. Okay. So we're just using this basically to pour some of our mixture in. Now, in your kit, in your general box, you've got some little cups, okay? You've got some little plastic cups. So if you grab one of the little plastic cups, so just grab one of those little tiny plastic cups. You can just use that look to lie the cell in, the cell body in, okay? I'll just wait. I think hopefully everybody's okay with that. You okay, Jeff? And little Jeffette? You okay? Yeah, cool. Right, so what you do now is you're going to put 3 scoops, 3 small scoops of your powder mixer, 3 small scoops, like that, into your filter funnel like that. And be careful, this powder gets everywhere, so you've got to be really quite careful, okay? So 3 small scoops of that powder into the filter funnel. So the small scoops, so not the big ones, the small ones. And then just give that a little tap look. Give that a little tap. Like so. You might have to keep giving it little taps because the powder sticks to everything, so just give it a little tap like that. Okay. Now, if you've got too much powder in there, if you accidentally put too much powder, okay, if you accidentally put too much powder in, just take the filter funnel out, okay, just put the filter funnel out and pour it a little bit back into the your other container, okay, and just put that back in there like that. As I said, don't be afraid if the powder gets everywhere. This is a very messy little experiment, okay, very messy little experiment indeed. Okay. And I find we've got enough in there. That's perfectly fine. Okay, so the next thing we need to do is put the little cotton cylinder. So if you get a little cotton cylinder, okay, into your tube and pop that in there like that. So work that in. Now you might need to use the little tiny stick, the little stirring rod, to poke that cylinder down, okay? So use the little stirring stick to poke the cylinder down like that, look. And don't be afraid to give it a little bit of a solid poke, okay? So give that a solid poke so you can feel it's compacting the powder in our tube, which of course is our cell. Yeah, so give that a little poke all the way down, nice and firm, nice and firm. And now we need the ammonium chloride solution, okay? So once you've poked that down, you've got a nice little tube. I'm just going to pause for a second to make sure everybody's okay. Is everybody okay? Yep. Got one thumb up. I haven't got too many other thumbs. No, everybody okay? Amelia, you okay? Uh-oh. Amelia, what went wrong? Ask to unmute. Ask to unmute Amelia. Hi, Amelia. How can I help? Hi, Ash. Can you unmute Amelia? Hi. Ask to unmute. Ash. Hi, Ash. Can you unmute Amelia for us? I think, yeah. Go.
So, like, we were lagging and we don't know what to do.
Oh, don't panic. Okay, so where are you?
We got to put in just got to put in the carbon in the tube, the carbon mixture. So
you created your mixture?
Yeah.
Oh, cool. Okay, no worries. So don't fill the whole tube full of the carbon mixture because sometimes you only need maybe 1 or 2 scoops. Okay.
We got that part.
You've got that, fantastic. Then what do you need? Have you got your little cotton stopper?
Okay, we didn't get this part.
Okay, so just get one of those and pop it into the top of the tube, which is going to be your cell body, and then ram it hard down into the thing with your little stirrer like that. So ram that down like that.
Okay.
Is that okay?
That's great. Yeah, lovely, thank you.
You're very welcome, it's not a problem. So please do, you can ask me to stop at any time, ask any questions, that's what the live webinar is for. Okay, so once you've done that, you need the ammonium chloride, okay? So the ammonium chloride with a white bottle. Now this is a liquid, so we need to, again, remove the safety plug from the bottle itself. So you need to go find your paper clip again. So again, once again, look, using your paper clip, you just depress the little safety plug so we can get access to that liquid. Now that one actually came out quite easily this time. And now once you've done that, you need about 7 drops, and be careful with the ammonium chloride into the top of your tube, okay? So put 7 drops, look, of ammonium chloride, I'll just push that bottle around a little bit, into the top of your tube like that. Okay, so 1, 2, 3, 4. Now you'll find sometimes that the liquid stops, it just stops and gets stuck at the top of the tube. If that happens, just use your little stirring rod again, look, and just poke it in a little bit. Just might need to give that little poke at the top to encourage the liquid to soak into the top of your little cotton stopper there, look. So just give that a little prod and a poke to encourage the liquid into there, and then again put a few more drops in. So I've put about 7 drops in now, and then just give that a little prod into the top of your cotton stopper. Okay. Is that okay? Yep. Cool. Right, so once you've got that now, the next thing to do is just give that a little squeeze, to work it in, just a little squeeze to work it around. You now need to get one of the zinc bolts. So these zinc coated bolts, actually an iron bolt, but it's coated in zinc, okay? So iron coated zinc. So you then get that bolt and just screw it in to the top and screw it down. So make sure the whole lot is nice and tight, and there we go. So we've now effectively created a cell, an electrochemical cell, which is very, very like this one, okay? So that is the equivalent of our cell, okay? So this side is positive, and that side is negative, and the zinc side is negative. So effectively, that's what we've created, okay? So, now, we need to create 2 of these. Okay, so now what you've done, the same thing you did with this one, we need to create 2 of these. So we need to create 2 cells in order to make a battery. So I'll just do that whole process again for you and show you how that's done. Again, just so if you can remember how to do it, then crack on. So again, look, we just need, first of all, to put the little tiny graphite rod stopper 3/4 of the way into the body of the thing like that. Okay, the body of the tube, that little tube. Yep. The next thing in is to get your little funnel, filter funnel, into the top like so. And then we've got to put, again, 2 or 3 of these little scoops, okay, 2 or 3 small scoops. Now, they are small scoops, okay, and sometimes can you see that it's very easy to heap this mixture on the top of the scoop. Oh, hi, I've got a hand up. Hi, Jake. Ask to unmute, Jake. Ask to unmute. Yes, Jake, go for it. Hi, Jake. Ash, could you unmute Jake for us? Hi, Jake.
Hi, Dan. Do we have to do 2 or can it work with just 1?
You have to do 2, yeah. You have to do 2. Is that okay? Yeah.
Okay,
Cool,
thank
cool.
you.
You're very welcome. Okay, so pop your mixture in there again. So 1 of those, 2 of those, and just tap that down to make sure I've got it. That's all there. Tap, 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 tap. And again, just wiggle it through, just wiggle it through. Okay, cool. So I've only used 2 of those because the, oops, I've dropped a load of the mixture because you can see it gets really messy everywhere you go. Okay, so now we get another one of our little tiny cotton stoppers and pop that in there and then use your little stirring rod to ram that down again, so pack that down tightly. So really important you make sure that mix is nice and solid, okay, that mixture is nice and solid. Ram that down. And then of course we get the ammonium chloride again and pop the ammonium chloride. So 7 drops, so 1, 2, 3, 4, 5, 6. And again, I might just need to encourage that solution to be absorbed by the cotton stopper. And just put 1 more in there like that, and then 1. So you might find that not all 7 drops fit in your particular thing. So just adjust it. So make sure you've got at least 4 or 5 in your little thing, and that will be fine. Then again, get your zinc coated after a little squeeze, of course, just a little squeeze, just to encourage that solution through the cotton stopper. So then get your zinc coated bolt and screw that nice and tightly down into the tube. So then we've made another cell. So that should be nice. There should be no gaps in here, no gaps. It should be nice and compact and solid all the way through, okay? So now I've got 2 of these. We've actually created 2 cells, which you won't believe, but you will believe when everything starts to work, okay? Now it might be at this point, a little tip is that your fingers will be now covered in sticky, zinky, gooey. So it's probably a good idea at this point just to give your hand, if you've got some tissue, just to give your hands a little wipe, okay? So just give your hands a little bit of a wipe with some tissue, okay, to degunge your hand. Right. So at this point, we need to label the cells, okay? So if you have your little sticky paper, you've got some little sticky paper here. So if you get the sticky paper, okay, I'm just going to cut I've got loads of sticky paper, but I'm just going to cut this one. Hang on. And what we've got to do is label our cells. So just going to move that out of the way, put the little top back on that one. Make sure it's a good idea to put the lid back on there just in case you knock it over and accidentally spill powder absolutely everywhere. And then try and get this sticky label to work. There we go. So I'm going to put that little sticky label there. And mine's not sticking very well to this one. Yeah, mine's not sticking. Unfortunately, my one's not sticking terribly well. Is everybody else's sticky paper working okay? don't panic about the stick. If you just remember, we don't have sticky labels. Pearl, don't panic. If you don't have the sticky labels, don't panic. If you could just remember that the carbon end is positive, and the zinc thing is negative. So just remember that the carbon end is positive, and the zinc end is negative. Okay, I'm going to just move that little bit of a mess out of the way. Right, so now what we need to do is assemble our clock, okay? And as we know, you've probably all seen little motors like this. You've got a little tiny motor in here, and that needs electrical energy to work, okay, electricity to work. So we just need to assemble our clock, okay? So first things first, take out your pack of bits and pieces. So take out all of it. Now you'll notice there's a bit of cardboard in here. The cardboard is to hold the sharp little tiny second hand, okay? Now, you're going to need to use a very delicate amount of force, but a reasonable amount of force, okay, to put the clock. So here the clock is going to hang up from this thing. So put 12. Oops, I don't have sticky labels. Don't panic, don't panic, don't panic. Okay, so put the 12, look where the pointy bit of your clock is, because that's where you're going to hang it up, unless you want to hang your clock upside down, of course. Okay, so see where the top bit is here. You're going to put the 12 facing up towards in the direction of that hook, and then just depress the whole thing down onto the clock face. Yeah, it should click through. If you leave the clock mechanism here flat on the table, and then very delicately just push it all the way down, so it should click through. Yeah, is that okay? You okay, Jeff? Is that right? Amelia, Henry, Pearl, Sophia, Ben, everybody okay? Yep, cool. Right, okay, so then let's put the rest of the clock parts on, okay? Everybody okay? Yep, cool, Pearl says excellent, fantastic. Okay, so the first thing we need to put on is the big washer here. So you put this washer here, look. And you can see it's got some striations here, some little raised edges here. So push that on there like that. So pop that on and force that down like that. The next thing we need to put on is the washer. So the washer will sit, hopefully that doesn't fall off the table. The washer, look, will sit inside that ring there like that. So pop that washer in. Then the next thing we need to do is put the screw. So you've got a little tiny threaded bolt screw here, okay? So you put that on there like that, and then just screw that down. So that it's a little bit fiddly. It's a little bit fiddly, so you might need just to pick that up to make sure the thread takes, and then just screw that lot down there like that, very gently, like so. I'll just pause there for a second. Hopefully that's okay with everybody. Yep, we're cool. Excellent. Oh, lovely. Thanks, Jeff. All right, so the next thing we need to do is put the hands on. So the hands go from the smallest to the largest, okay? So the first one is the hour hand. So again, just delicate, they're quite delicate little hands, these. So if you just very gently with all 4 fingers, just push it down and push the hour hand down on through the thread. Like so. Okay, then you want to put, so I'm just going to move my hour hand to say 9 o'clock. And then you put the minute hand. So then do the same thing with the minute hand. So pop that gently down like so. I'm going to make that then 9 o'clock on my clock. And then last but not least, you have to put the second hand in. And then pop the second hand. Now you see the second hand, look, has got a little hollow thing, and that sits over the pointed mount in the center of your hand mechanism. So pop that in like that. Okay. And we're almost there, folks. Almost there. Okay. How are we doing? Everybody okay? Lovely, nice one. Lovely. Jeff has got and little Jeffette has got a nice clock. Lovely, that's fantastic. Yes, yep, cool. How are we doing, Henry? Pearl, Sophia, Ben, Amelia, we're all okay? Nice one, lovely Jake. Fantastic, fantastic. Yep, that's lovely. Right, now the magic is about to take place. The magic's about to take place. Right, remember what I said about your batteries, okay? Is that the zinc end, of course, is negative and the carbon end is positive. So we need to sit this into the mechanism that drives the clock. So here we've got the cell batteries. This isn't a battery compartment, it's a cell department. So remember, look, the carbon end, if you look at the back here, look, you can see there's a faint outline that says positive and negative end, so positive and negative end. So check that out carefully. And if you get your carbon at the positive end and the zinc at the negative end, you may find, look, that it's just a little bit too narrow. You may find it's a little bit too narrow. If it is, you just need to adjust the screw a little bit, the bolt, and also the carbon. Okay, so you just might need to adjust the screw and the bolt a little bit. So mine was a little bit too short, just a little bit too short. So I'm just going to adjust that a little bit to make that kind of work. And anyway, so just give it a little bit of a wiggle bit and a little bit of an adjustment. And with any luck, that should work. Oops, hang on. Just stop that there. And hey presto, I've got a clock that works. How cool is that? How cool is that? I've actually just made, or you are just about finishing making your own homemade cell. How amazing is that? And that's not a battery. Remember, it's not a battery. I must turn that up the right way. Turn that up the right way. Is it working? Jake, working? Yeah, so the battery, not working. No. Okay, let me answer some questions. Ask to unmute. Ask to unmute. Jake. Hi, Jake.
Yeah. Hi, Dan. Mine seems loose, but I'm not sure how to fix it.
Oh, right. If it's loose, make sure that the clock face, first of all, here, the clock face is pushed right down. Sometimes it needs to click into place. You need to use a little bit of pressure to make sure it's clicked. And then when you put the bolt on, you know, the threaded bolt, you need to screw that down quite tightly. And that will normally fix the whole mechanism into place quite nicely.
Let's have a look. I'll put it down for us. So thank you.
Thank you, Dan.
You're very welcome. You're very welcome. It's a pleasure. And don't forget, when you put the battery in, the cell in rather, the copper, the zinc end is negative, and that's on the spring. You'll see that in the back of the mechanism there's like a little spring mechanism, and then there's the flat end, and the flat end is the positive end. Okay, Pearl, it works. Excellent. Isn't that amazing? So you've got a fantastic little clock. Right, I'm going to leave that down for a second before we do some more lights. I'm just show you a little bit more about why it's working and explain a little bit of the chemistry, okay? And then hopefully answer anybody's questions. Okay, I'll just put the slideshow on for a second. So what's actually inside an alkaline cell? In fact, I'll just go back to the zinc cell actually. So you just made what's effectively called a dry cell, okay? A dry cell. So basically you have the metal rod, that's the cap, that's the zinc bit effectively. Then inside it you have what's called a paste of manganese oxide and ammonium chloride. And hey presto, what did you have in your kit? You had ammonium chloride and manganese oxide, okay? And then, so we've got the zinc in contact with this substance, with the ammonium chloride, okay? And that basically is what makes up all dry cells. So you just made up your own very messy, very rudimentary, but it works, dry cell, okay? So what is the chemistry? What's actually happening here? Okay, let me explain that. Okay, so what's actually happening chemically is two processes in chemistry called oxidation and reduction. And basically, it's all about electrons. Some substances are giving electrons, and some substances are taking electrons. And in that giving and taking process, which is continuous here with the flow of a current, okay, some substances are losing electrons, they're becoming ions, negatively charged ions, and some are becoming positive ions. So like the salt that you eat, for your salt fish and chips on a Friday or something like that. Okay, that's sodium chloride. So here, look, is sodium reacting with chlorine to produce sodium chloride. But in terms of electrons, that's what all of this is happening. It's all electrochemistry. Okay, the sodium went from sodium metal. It lost an electron to become a sodium ion. And the chlorine gains an electron to become a chloride ion, okay? So it's all like giving and taking electrons. So the sodium lost the electron, okay? And it's oxidation if it loses. And then the chlorine gained an electron, so that's reduction. So reduction is gain of electrons. And so what's happening in our cells here, okay? Where that little zinc bit is, can you see here? This is your zinc end. This is the zinc top of your cell. The electrons itself, the atom of zinc, an atom of zinc, is leaving the zinc to become a zinc ion and losing electrons, which then flow around the circuit. Okay, and when they come to this side, okay, the positive side, the manganese oxide is collecting the electrons. Okay, collecting the electrons. Okay, and it's changing. Okay, and so what's actually happening here? Look, you see how the zinc is losing 2 electrons. And at the bottom of the equation, look, this is the substance here we made, that messy powder with the carbon. But the carbon really, don't focus on the carbon too much, but focus on the manganese oxide here. It gains the electron, okay, and changes form, okay? Is that okay? So that's what's happening continuously while that circuit is connected up. Does that kind of make sense? And I got Henry's put a shot. Phase. Okay. Right. Is everybody okay? Has that worked for everybody? Has everybody got a clock that is telling the time? Nice one, Henry. Absolutely wonderful. Absolutely wonderful. Absolutely fantastic. Okay, that's great. Absolutely great. Yes, fantastic. And Amelia, we have a clock on the wall, the cheapest clock on the wall. Okay. So you now know that next time you run out of cells and batteries, you know exactly how to go and make your own. So one last little trick we can do. Yes. Okay, one last little thing we can do with our setup, of course, is if you get your battery pack back again, now we're going to use both of both of the cells that we made to make a battery, okay? So to make the battery, all you need to do, look, remember the positive end, and so the zinc is negative, and the carbon is positive. So you can put, look, fill your battery pack again, so push that down and make sure there's a right connection there. And then do the other side. So we've created our own little battery pack like so. Now remember, the red end here, the red lead, you connect to the bent leg, okay? So the red lead, you connect to the bent leg. I'll just show you that, look carefully like that. The red lead, you connect to the bent leg, and the black lead, you connect to the straight leg. And with any luck, oops, haven't got the connection going, and I might need to change my LED. So I will change my LED. That's all connected up okay. I'll just check to make sure the connection's okay. So red leg to the, make sure that's connected, and then hopefully, hey, voila, you should have a little LED. Is that working? Yay! Fantastic. Absolutely fantastic. Henry, full marks. Amelia, Jeff, Jake, Sophia, Ben, has that all worked for you? Is that all? I'm just going to change to face time. Hang on, face camera. Cool. Has that all worked? Yay! I bet you didn't think it was possible to make a battery or an electrochemical cell. Fantastic. That's lovely. Any questions? Any questions? Have we got any questions? Was that all a bit of fun? Cool. So I'm just going to leave a couple of minutes for you. If you want to ask any questions, you can ask to unmute if you would like. hopefully you've enjoyed that. Hopefully it was good fun. There's a little poll there, so it's always nice to hear your comments, and positive or negative. Of course, it would be positive and negative. It is actually what? Mate, you're doing one next week. Amelia. Yes, Amelia, I'm next week. As I will be doing on Wednesday and Thursday next week. I'm doing both of the webinars next week. I think I'm doing... No, Wednesday I'm not doing the webinar, but Thursday I am doing the webinar, and then all the way through February I'm doing all the webinars through for February. So I really hope to see you at that point. So, young Jake, lovely to see you again. Lovely to see you all, in fact. I hope you had some success with that. Be careful with the sticky sludge and the powder and stuff like that. Soapy water, warm soapy water will come off. And in which case, I will love and leave you. And I hope you have a fantastic weekend. And I really look forward to seeing you next time. So do feel in the positive. If it's positive, do leave some positive comments. That'd be really lovely. That'd be really great. It always helps me and it helps company. So thanks, Jake. You're very welcome. An absolute pleasure and a delight. So on that note, I will then say goodbye.